reciprocal identities, I feel like we know these, and whether we can write them or not is a different thing. So like, I feel like you know that the cosecant is the reciprocal of the sine. Okay, I feel like you know that, but you know to write it. That's called a reciprocal identity. Or the secant is the reciprocal of the cosine. Or the cotangent is the reciprocal of the tangent. Now, heads up, some teachers teach that there are 6 reciprocal identities because they would also want you to write that the sine is 1 over the cosecant, and the cosine is 1 over the secant, and the tangent is 1 over the cotangent. I've even seen some teachers write it as more identities than this, where they would say, well, the cosecant squared is 1 over the sine squared. The secant squared is 1 over the cosine squared. The cotangent squared is 1 over the tangent squared. So I've seen people make 3 reciprocal identities into many more. But as long as you know these 3, I feel like we can manipulate those instead of writing down a whole bunch. Okay, quotient identities. Now, quotient means to divide. And I always think like, okay, divide what? Well, let's divide the most common trig ratios that we know about. Like we're going to divide sine by cosine. And when we divide sine by cosine, we get tangent. Well, if we divide sine by cosine to get tangent, to get cotangent, we're going to divide cosine by sine. And if you wanted to know why this is, why are these quotient identities so? Well, if you think about what the definition is, sine is always y over r, and cosine is always x over r. So if you divide y over r by x over r, you're really multiplying by the reciprocal. So don't divide by x over r, multiply by r over x, and look what you end up getting. You end up getting y over x, which is tangent. So it just is the relationship algebraically between sine and cosine. When you divide them, you get tangent. And I like to remember this because, well, if I say them in order, sine, cosine, tangent, I can kind of see this identity. Also, cotangent has the cosine on the top. So some little things I look for. Okay, Pythagorean identities. Now, these I remember with sentences that my students have made up throughout the years. The first one is sine squared plus cosine squared equals 1. And I remember the sine costs $1. Sine costs $1. Sine squared plus cosine squared equals 1. I got tangent squared plus 1 equals secant squared. And that's tan in 1 second. I love to be tan. Wouldn't it be nice to be tan in 1 second? And then finally, I've got 1 plus cotangent squared equals cosecant squared. And this is 1 coat from Costco. Costco is CSC. 1 coat from Costco. Now, these are Pythagorean because they all stem from the relationship between a squared plus b squared equals c squared. And so I know this has to be squared and that has to be squared. And instead of writing 1 squared, I mean, 1 squared is just 1. But keep that in mind. It's what something squared plus something squared equals something squared for Pythagorean identities. And then finally, my negative angle identities. Well, I set these up. So I say, well, what happens when I take the sine of a negative angle? What happens when I take the cosine of a negative angle? And what happens when I take a tangent of a negative angle? So I set them up. I just say, okay, what's the relationship? Well, I have to remember that the sine and the tangent are odd, meaning when I take the sine or the tangent of a negative angle, I get the opposite of the sine of the positive angle. I get the opposite of the tangent of the positive angle. And we'll talk more about this today. Graphically, we'll see how those are odd. They're symmetric across the origin. Whereas cosine is even. So when I take the cosine of a negative angle, I get the same thing as the cosine of the positive angle. And these go with the reciprocal identities as well. So if I asked you for the cosecant of a negative angle, you would say, well, that's odd. So it's the opposite of the cosecant of the positive angle. All right. Okay, so note 6.4a, I said recall, and this is a true recall. I know last time I wrote recall and you were like, well, I've never seen these before with the identities, but this is a true recall. You have seen this before. Y equals the sine of theta graphically. So let's take a look at what y equals sine of theta graphically looks like. So I'm going to create a graph I'm going to focus on the positive x-axis. And I'm going to graph one cycle, or what we call one period of the sine function. To graph one period, I'm going to go around the unit circle one complete revolution, which is 2 pi radians. So when we graph, we label our x-axis in radians. Now to graph the sine of theta, I'm going to actually think about this little quadrantal trick. The quadrantal trick has a 1 on the top when I write sine, and it has a -1 on the bottom, and it has a 0 on the left and a 0 on the right. And why does that help me to graph this? Well, it's telling me when I take the sine of 0 radians, I get a y value equal to 0. So this tells me that 0, 0 is an ordered pair when I'm graphing sine. Now, when I move up to pi over 2, it's telling me I'm going to go up to 1. When I move to pi, I'm going to come back down to 0. And when I graph 3 pi over 2, I'm going to go down to -1. And then at 2 pi, I'm back to 0. So I'm going to label this in terms of one cycle. So let me split my 2 pi in half, and I'll get a pi. And I'll split that in half to get a pi over 2. And then in between pi and 2 pi, I've got my 3 pi over 2. So I have these 4 kind of segments in here that make up my one revolution. We're going to go as high as 1 and as low as -1. But we can never go beyond that because remember, sine is opposite over hypotenuse. So we want to make sure that it makes sense that the hypotenuse is the biggest number. So I'm going to go from 0, 0 up to 1 at pi over 2, back down to 0 at pi, down to -1 at 3 pi over 2, and then back to 0 at 2 pi. And I get what we call a sinusoid, which is a wave, nice and smooth. Try not to make it jagged. And we're going to put arrows at the ends always to indicate that this cycle does not stop. It continues to go. In fact, I can show you that sine now is an odd function. You can see sine is an odd function because if I take the sine of pi over 2, I get a +1. But if I were to take the sine back here at -pi over 2, I would get an answer that was opposite. I would get a -1. So this is a graph that's symmetric across the origin. It's an odd function. Okay, let's graph the cosine. So I could also use that, that little memory cue to help me to graph the cosine if I wanted to with quadrantal angles. So I'm going to graph to 2 pi. I'm going to split that in half to pi. Let's split that in half to pi over 2. And right here we'll graph 3 pi over 2. This guy's going to go up as high as 1 and down as low as -1. And if you didn't know where the values were, you could always go back to this little memory cue and say, well, cosine has a 0 on the top and a 0 on the bottom at 3 pi over 2, but a -1 to the left and a +1 to the right. Meaning this tells me when I'm at 0 on my angle, I'm going to start up at 1. So cosine starts up at the top. And cosine says top, middle, it goes back to 0, then down, so bottom, and then back to the middle at 0, and then back up to the top at 1. So it says top, middle, bottom, middle, top. Somebody said cosine looks like a cup, but be careful, be careful. You don't want to go any higher than 1 and be really picky. Can everybody look at my screen real quick? Look, 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 look. Look at my screen. Don't ever go higher than 1. What I mean by that is this wave is going to come from down here, hit its peak, and then it's going to curve like a cup, like it could hold some water, and then it's going to curve back down. This is really hard because if you were in class with me right now, I'd totally run around the room and I'd make sure that your cosine curve curves downward as the cycle. It doesn't continue to go upwards. Okay, how about this? Nod your heads yes or no. Do you remember doing this last year? Nodding yes or no. Oh, that's much better than identities. Sorry, guys. Okay, that makes me happy. Excellent. All right, so what are we going to do? Well, we're going to do all the stuff that you did last year. And we're probably going to do it a little quicker because this is honors pre-calc. You know, you're all fancy. But a general form of the sine and cosine function is this form that I typed here for you in the notes. And so if we have sine, we're going to mess with how often this occurs, so we can shrink it down so it occurs faster, and we can stretch it out so it takes longer. We can also stretch it taller and shorter, and we can pick it up and shift it left and right. So all of these things are affected by my A, my B, my H, and my K. Oh my gosh, H and K, that never goes away. From first semester, we did a ton with H and K. All right, so these are my forms. The first one we're going to take a look at is what does B do? What does B do? So this is huge right here. I'm going to highlight it. I'm going to color it in my yellow. Here, the period, how long it takes to repeat. So let me write that here. The period, which is how long it takes to repeat. The period, how long it takes to repeat, is affected by the B value. It's affected by the B value. So let me show you that. It says determine the period of y equals sine of 2/3 theta. So the number before the theta is always the B value. Now the number in the front, I'm always going to look for a number in the front. The number in the front is just an A value, and we'll talk about what that does. That's your height, your amplitude. So A is 1, meaning from my center line, I'm going to go up 1 and down 1. So I haven't changed anything there, but it's this number here that changes everything. This is a B equal to 2/3, which means when I'm calculating the period, I'm going to always do what I highlight in yellow, 2 pi over B. So we're going to take that one cycle, 2 pi, and say, well, wait, that's affected by that 2/3 in this equation. So we do 2 pi divided by B. Well, let's see, 2 pi divided by a fraction is the same thing as 2 pi times the reciprocal. Since I divide by 2/3, I multiply by 3/2. And look, my 2's are going to cancel. So this is saying the period is 3 pi, meaning it's going to take 3 pi to repeat. So guys, I'm going to take this sine function here, and I'm going to stretch it out so it takes longer to repeat. It's moving slower around the circle. Now it takes a full 3 pi to repeat. How do you do that graphically? Well, instead of labeling my last point here 2 pi, like our standard sine wave, we're going to label this guy here 3 pi. This graph takes 3 pi to repeat. So now when I split it in my 4 little segments, I have to think, numerically, I have to think, well, what number would this be here? Well, when I take 3 pi and I cut it in half, I'm going to get 3 pi halves. When you take a number and you cut it in half, you just double the denominator. We do it again. Look, I'm going to cut this 3 pi over 2 in half. Or I'm taking the average of 0 and 3 pi over 2. So when I do that, well, half of 3 pi over 2 is 3 pi over 4. I don't know if I have any gamblers in the room, in the virtual room here, any gamblers, but doubling down is something you can do when you play blackjack. That's what you're doing here. You're doubling down. You're doubling the denominator. When you cut something in half, you double that denominator. Okay, this guy is the hardest one to calculate right here. This guy is the hardest one to calculate because I really have to understand my fractions. This guy is the average of this number and this number. This one right here, so let me make a note here. Just gonna kind of put an arrow. This one is the average of 3 pi over 2 and 3 pi. And the reason why I'm talking about averages is because the numbers are going to get funkier as we get through the chapter. And so if I really think about an average, it doesn't make it too tough. See, to find an average, you add 2 numbers together and then you divide by 2. So if you think about that, you're taking 3 pi over 2 plus, well, 3 pi is 6 pi over 2. So you add them together and then you divide by how many there are. So this is the calculation that I'm really thinking about doing here. Let me add these together and divide by 2. And as some of you, if you were in the room, you'd probably like, no, 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 but you're too polite to unmute and say no, no, no. What I mean by that is I know that there's other ways to get this, but as we pick things up and move them left and right, I really want you to start thinking about averages. So you add them together to get 9 pi over 2, and then you're going to cut in half or double the denominator to get 9 pi over 4. Now, if you're thinking of different ways to get that, because this is 0, another way you could have gotten that is said, well, one step is 3 pi over 4. So if you multiply by 3, you're going to get this step here, which is 9 pi over 4. That's another way to think about it. Or some students like to step. They go like this: 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. So you can kind of step through it. But I'm going to focus on the averages because we'll use that a lot. I'm really focused on this, have you noticed? Because this is usually the hardest part for students. Are we okay? Are we all right? Nodding, nodding. Yes, okay. Here we go. So the last thing you need to know, well, the amplitude was 1, so the height was not changed. It goes up to 1 and down to -1. And this is sine, so you need to know that sine says middle, top, middle, bottom, middle. Okay, and then we go ahead and we graph our wave like this. Arrows at the ends, just like that. Da-da-da-da. Now, I don't really focus too much on drawing these to scale. What I mean is I tried to draw it a little bit longer, but I hope you realize what we just did is we took this snake here, this sine snake, and we pulled it out a little bit so it would take longer to repeat. If there are no questions, and let's talk more about that amplitude. Let me check that chat there. Okay, nothing's in there yet. All right, well, let's talk more about the amplitude. So the amplitude says it can be determined by the formula absolute value of A. Let me talk about that for a moment. Amplitude means height. And so they say the amplitude equals half the difference between the maximum and the minimum values. Meaning, if I want to know what's the amplitude of this graph, that means what's the height from the center line. So we go up 1 and we go down 1. That's why it says half the difference between the top and the bottom, because this is too tall. It's 1 up and 1 down. So amplitude is height. Now, why do they say absolute value? Because usually when you say how tall is something, you don't give a negative height. That doesn't make sense. And also because if A is negative, that's a huge important idea. If A is negative, the graph is reflected, or it's flipped upside down. So let me show you what that means. I'm going to look at this example here. It says y equals -2 sine of x. And so I can see here that my amplitude all of a sudden has a negative there. Now I'm going to write the amplitude is +2. Heads up, heads up. I always write that the amplitude is a positive number, and I want you to write that as well. Always write that it's a positive number, but as soon as I see that negative, I make myself a note that I know it's going to be flipped. So the amplitude is a positive number, but it's going to be flipped. Now, don't forget that B number. The B number is in front of the X or in front of the theta. They'll use all sorts of variables here. You can use an X, a theta. Sometimes you see a beta. Okay, you can use any numbers here or any variables here. But in front of the X, that's where your B is always going to be located. So I don't want you to forget to look for B. In this case, B is 1. And so that tells me that the period is 2 pi over 1. Okay, good. So this period did not change from my initial example. This is going to take 2 pi to repeat. The reason why I love when it takes 2 pi to repeat is because I've got these numbers down. I really don't have to think about them too much. I know that that's 2 pi. I know that this is pi. I know that this is pi over 2. And I know in between is 3 pi over 2. So that's nice. I like when the period is 2 pi. Okay, so the amplitude is 2. What does that mean? It means you're going to take this sine wave now here, and you're going to stretch it to be taller. From the middle line, it's going to go up 2, and it's going to go down 2. How do we draw that here? I mean, if you want to draw it to scale, you could elongate this and make this higher at 2 and make this lower at -2. But really, you don't have to worry about drawing too many things to scale. So if you just label this 2 and -2, good, you're good. Be careful. You ready? The sign starts at the 0, and it normally says middle, top, middle, bottom, middle. But notice this was flipped. So I'm going to go middle, bottom, middle, top, and then the middle. That guy got flipped because the A was a negative. So this wave snakes down first, and then comes up and goes back down with arrows at the end. The amplitude is 3, it's this number here, and then the period is 2 pi over b, and in this case, since b is 2, now some of you told me what b was, okay, but b really doesn't have any significance graphically except the effect that it has on the period. So 2 pi over 2 is pi. So if you told me that the period is pi, you're good to go. Now what that means, this is kind of cool. Think about this cosine wave. This cosine wave, I'm going to shrink it down so the whole wave occurs within a pi. There's going to be a lot of action going on much faster. This guy's faster, a faster cycle, and it's really, really tall. So if you think about taking this U shape, shrink it down, smush it down, and then stretch it tall, that's about what we're supposed to do. Okay, so how do you graph it? Again, I'm not too picky about graphing this accurately. I mean, maybe I'll make it a little bit shorter just to emphasize the action is occurring faster. So I'll make that pi, cut that in half to make that pi over 2. Now think about these numbers. I'm cutting this in half to make this pi over 4. We double down, double the denominator. And then this guy right here, right there, is the average of pi over 2 and pi. And I hope you know that between a half and a whole is 3/4. So that's 3 pi over 4. Now this guy really should be way, way tall. I mean, I'm just going to label this 3, and then maybe I'll go down a little bit more, label that -3. But I wish I had more space. I'd make it really tall, kind of more fun. Okay, be careful. This is cosine, 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 and cosine looks like a cup, meaning it starts at the top and it should hold some water in there if you're looking at one cycle. So cosine starts at the top, top, middle, bottom, middle, top. And we make sure that it's a wave, that 3 is the highest possible number. So don't let it go beyond. If I were to graph like a horizontal line here, you shouldn't exceed that horizontal line. You guys, we are almost there. I haven't had many questions at all. I hope that's a good sign. Can you flip that page then and we'll wrap it up? Now we talked about what the B does. It affects the period. We talked about what A does. It affects the height. And then as you flip your page, we're going to talk about what K does. And just like graphing quadratics or radicals or all the things you graph first semester, K, even conics, we graphed lots of conics. K is going to affect that vertical shift. So K has an effect on that vertical shift up and down. So what I'm telling you now is this number that hangs off the end there, that K number, it's going to pick up our waves, place them upwards and plop them down, or pick them up and move them downwards. If K is a positive number, as we know, the graph is going to shift up. And if K is negative, then the graph shifts down, meaning K is true to its sign. Unlike H, oh man, H gets its own day because H is the toughest. H in the parentheses moves things left and right. So we don't even want to talk about that right now. H gets its own day. All right, so we got 3 things to talk about now. We've got an amplitude, a period, and a vertical shift. This first thing I'm going to boo here is that this pi over 4 really needs to be out front of the parentheses. So that'll affect down the line, but just know that this number here is my B. That pi over 4 is the B. The book likes to put them in parentheses. We want to take them out of the parentheses. You'll see why in the next couple days. Okay, I'm going to go through and label everything. You ready? So amplitude is 1/3. So this guy's super short. Amplitude is 1/3. The period equals 2 pi divided by pi fourths. Well, that is 2 pi times 4 over pi. When I divide by pi fourths, I multiply by the reciprocal. These pi's cancel, which means the period is just going to be 8, which is totally fine. If my period doesn't have pi's in it, that's okay. Sometimes pi cancels. So far, amplitude is 1/3. The period takes 8 to repeat. And finally, they wanted the vertical shift. So I look at this number hanging off the end. That's the new piece. That's my K. And my K is a -3. Now I like to write k as -3, or sometimes you're going to actually see me write the words down 3. Just telling my brain this guy's going to go down 3. Ladies and gents, this did not ask me to graph. Do you notice that? And I want you to pay attention to that on the e-text. Please don't do too much homework. If it doesn't want you to graph, please don't graph. Okay, don't do too much work tonight on your e-text. Read those directions. So let's do it again. Now this time, you see how this 2 is in front, 2 minus, and then 5 times that? I think they're being mean there. I want you to recognize this 2 as the k value, which is really added to the end. So if I have some sum in the front, I like to kick it to the end, and then I'll say, oh, this number here, that's my k value. So this k is going to be 2, meaning I'm going to take this entire graph and I'm going to shift it up 2. So you can write +2, or you can write the words up 2, whatever you want to write. Or, I'm going to write or, whichever you prefer. Hey, let's go through and label the other things because they wanted the other things too. Amplitude, watch out. See how amplitude is a -5? I'm going to write amplitude as a +5 because that's a height, but I'm going to give myself a little note that it's going to be flipped. And then finally, I've got my b here, which is 3. So the period is 2 pi over b. Oh, that was nice. I didn't have to change anything there. So I've got an amplitude of 5 that's flipped, and I've got a period equal to 2 pi thirds. Let's put it all together. 5 minutes. This is so cool. We start putting it all together, okay? So take a look here. We want to determine the vertical shift, but we also need to think about A and B to affect the period. So I'm going to go through all the steps. A in the front of the sign is 1. That's nice. They didn't change that at all. K is this 3/2 number here. So this number here hanging off the end. So K is going to be up 3/2 or up 1.5. Up 1.5 for K. And then the period, well, it's 2 pi over B. Since B is 1, the period is just 2 pi over 1 or 2 pi. So this is really a nice problem. They didn't change too much on me. Ready, guys? Putting it all together. I am always going to still graph my x and my y-axis. Now listen, this K line, the middle line now, has gone up to 1.5. What that means is I am going to write 1.5, and that is my middle line. So I like to give myself a little K line. I actually call this the K line. Because when I say middle, I know I need to hit the K line. That's my new middle. So if you think about the height then, I need to go up 1 from there to get to 2.5, and I need to go down 1 to get to 0.5. So the highest this graph is going to go is 2.5, and the lowest is 0.5. I have everything I need now. This is a sine wave, and sine starts in the middle. And the sine said, oh, I guess I should label this guy, huh? 2 pi. I'm glad that didn't change. Pi over 2, 3 pi over 2. Okay, the only thing I've changed so far is from my middle line, I need to go up 1 and down 1. So sine says middle, top, middle, bottom. Be careful, bottom is here at 0.5, and then middle. I have had some students that like to graph the middle line, and then they also like to do that top line. So if you prefer to give yourself the guidance of the middle and the top and the bottom, you certainly can. But sine says middle, top, middle, bottom, middle. Ooh, that chat is quiet today. I hope you guys are doing all right. I'm going to take this as a good sign that you're remembering this. And we'll just wrap it up. Can you go backwards, I guess, at the very end here at the last few minutes? Can you go backwards? Oh, I forgot to say one of my favorite sayings. Well, I'll do that here, okay? So can you go backwards? Can you look at this and say, well, look, my middle must be at 0. Because from my K line at 0, I go up and down A, so A must be 5. In fact, A must be 5, and this is a sine wave, middle, top, middle, bottom, middle. I like this saying, from K, I go up and down A. It's my nice little rhyme there. From K, up and down A, from K. So I figure out where is that middle line, so I go up and down the same amount. And I knew that because this was 10 tall, so I had to go up and down 5. Okay, so I've got a K, I've got an A. Now notice the period here is 4 pi, right? It took 4 pi to repeat. So if the period is 4 pi, that means 2 pi over B is equal to 4 pi. So you can actually figure out what B is. You can just think about what B is, or if you wanted to maybe write 4 pi over 1, you could cross multiply. 4 pi B equals 2 pi. So B would be 2 pi over 4 pi. So B would be 1/2. So then you would just put it together here in the last few seconds. Y equals A, which is 5, times the sine of B, which is 1/2, times theta, or x, and then plus 0 off the end. I'm not going to write a plus 0 because there was no K.